If you could step into a time machine and travel back 300 million years, the Earth you would see would not look like the Earth you know today. There would be no familiar outline of North America or Africa, no Atlantic Ocean stretching across the middle of the planet, no scattered continents spread out like puzzle pieces. Instead, the world was joined together into a single vast landmass, a supercontinent called Pangea. Imagine standing on the shore of this ancient Earth. Behind you stretches endless land, a continent so massive you could walk from what is now Florida all the way to Morocco, or from the east coast of South America to the heart of Asia, without ever crossing a sea. Before you lies an enormous ocean, the Panthalassa covering most of the planet's surface. On this world, almost all the dry land was fused into one giant piece, and all the water was gathered into a single endless sea. The story of how Pangea came to be begins long before its time. For billions of years, the continents of Earth had been on the move. They ride on the slow but powerful motion of tectonic plates, huge slabs of rock floating on the mantle beneath. At first, the continents were scattered. Over hundreds of millions of years, they drifted toward one another, colliding and merging like pieces of a cosmic puzzle. Around 35 million years ago, during the late Paleozoic era, they finally came together, forming Pangea. To picture the size of this supercontinent, think of today's continents pressed tightly against one another. South America's eastern edge fits neatly against Africa's western coast. North America joins Europe. And Greenland, India is still attached to Africa. Australia and Antarctica lie tucked below. It was as though the world had gathered all its land in one place. Scientists estimate that Pangea stretched nearly from the North Pole to the South Pole and covered about 1/3 of the Earth's surface. This was the age before dinosaurs ruled the land. Giant amphibians crawled through swamps, primitive reptiles, some no larger than lizards, others as big as crocodiles, scuttled across the dry ground. Strange forests grew with towering ferns and conifers. The air itself was different. Oxygen levels were higher, and the climate was harsher. But to understand Pangea, the most important thing is not just its size, but what it meant for the planet as a whole. Think about how different life would feel on such a world. Today, the oceans shape our climate. They bring moisture inland, soften temperatures, and carry winds across great distances. But on Pangea, the center of the continent was so far from the sea that rain rarely reached it. The heart of Pangea was dry, harsh, and desert-like. Meanwhile, the coastlines stretched for tens of thousands of kilometers, battered by winds and storms rolling in from the great ocean of Panthalassa. And this world was still changing. Though the continents had come together, the forces beneath Earth's crust never stop. Mountains rose as plates collided, volcanoes erupted, spilling lava onto the land. Earthquakes shook the ground. Pangea may have looked like a stable, unbroken land, but in truth it was restless, and its story had only just begun. As we stand at the edge of this ancient world, we cannot help but wonder, what would it have been like to live there? How hot would the deserts have been? How vast would the forests have seemed, stretching endlessly without the interruption of oceans? And how strange would it feel to know that all the world's land was joined as one? This was Pangea, a world both familiar and alien, a single continent, a single ocean, and a planet preparing for one of the most dramatic chapters in its history. When all the land of the Earth was gathered into one enormous continent, the climate was unlike anything we know today. Pangea stretched so wide and so long that it created extreme scorching deserts at its heart, heavy rains along its edges, and icy caps at its poles. The very size of the land shaped the air, the winds and the seasons. If we could walk through this ancient world, we would feel how unforgiving it could be. Think about today's continents. Europe, Asia, North and South America. They are all touched by oceans on every side. Even when you stand in the middle of a continent now, you are never more than a few thousand kilometers from the sea. And oceans matter. They act like the lungs of the earth, carrying moisture, breathing out winds, softening temperatures. But on Pangea, things were very different. The land was so huge that its center was thousands of kilometers away from any ocean. That meant rain could not reach far inland. Clouds would form above the seas, but by the time they drifted across the endless landmass, their water was gone. The result was a heart of dryness. A vast desert, stretching farther than the Sahara, covered much of what is now North Africa and the Middle East, reaching into Asia. Geologists call this the Central Pangean Desert. Fossil evidence and sedimentary rocks show us the truth. Sand dunes that hardened into stone, ripples preserved from ancient winds, layers of red rock baked under relentless heat. This desert may have been the largest Earth has ever known. Imagine standing in it. No rivers, no seas, just endless sand beneath a blazing sun. But Pangea was not only desert. Along its edges, where the land met the Pantalassa Ocean or the smaller Tethys Sea, the climate was very different. Here, warm winds carried moisture inland. Seasonal rains came in powerful bursts, much like the monsoons we see in parts of Asia today. Studies of ancient rock suggest that these monsoons were strong and predictable, shaping the growth of vast forests along the coasts. If you were living near the shoreline of Pangea, you would have seen rivers swelling with rainwater, great floodplains stretching across the land, and swamps filled with strange plants and amphibians. The poles of Pangea were colder, though not as icy as they are now. Around 300 million years ago, during the late Carboniferous and early Permian periods, Earth still carried ice caps, especially in the southern regions of what is now Antarctica and South America. But as time passed, the world warmed. By the middle of the Permian, around 20-60 million years ago, glaciers retreated and deserts expanded. Earth was entering a hotter, drier age. This shifting climate had powerful effects on life. Amphibians, which depended on wet swamps, began to struggle as the deserts grew. Reptiles, with their scaly skin and ability to conserve water, thrived instead. This change paved the way for the rise of reptiles across Pangea, including the earliest ancestors of dinosaurs. The climate itself was choosing who would flourish and who would fade away. Even the air was different. Scientists studying ancient coal beds and fossilized plants have found evidence that oxygen levels were higher during parts of the late Paleozoic era, perhaps as high as 30 to 35% compared to today's 21%. This made the air richer and may explain why insects grew to enormous sizes. Dragonflies with wingspans of nearly 70 centimeters soared over swamps, and millipede-like creatures longer than a human crawled through the forests. Imagine walking in Pangea and seeing a dragonfly as wide as your arm, or hearing the rustle of giant insects in the undergrowth. The climate was not stable, either. It shifted over millions of years, sometimes gradually, sometimes suddenly. Volcanoes erupted, pumping ash and carbon dioxide into the sky. This could darken the atmosphere for years, cooling the planet, then leave behind a warming world as greenhouse gases built up. Evidence of these changes lies in layers of rock bands of ash, sudden shifts in carbon isotopes that show the climate was always in motion. One of the most dramatic events tied to Pangea's climate came near the end of the Permian period. About 2,502 million years ago, massive volcanic eruptions in what is now Siberia released enormous amounts of carbon dioxide, heating the planet and making the climate unstable. Deserts spread even farther, seas grew acidic, and oxygen levels in the oceans collapsed. The result was the Great Dying, the largest mass extinction in Earth's history, when more than 90% of marine life and 70% of land species vanished. Though this happened after Pangea had already existed for tens of millions of years, it shows how fragile life was on such a world, and how much climate shaped everything. But if we step back and look at Pangea as a whole, we see a planet of contrast, a single supercontinent with burning deserts at its heart, stormy coasts along its edges, icy poles to the south, and forests in the zones where rain still reached. Life clung to each region in its own way, adapting to heat, dryness, or floods. The land was united, but the climates were divided. creating worlds within a world. To imagine Earth during Pangea is to imagine a place both familiar and strange. We know deserts and forests today, but never at such scales. We know monsoons and storms, but never sweeping across a continent so vast. The air itself carried more oxygen, the skies filled with creatures larger than anything we see now. It was Earth, but Earth magnified, an ancient planet with its extremes pushed to the limit. And as the climate shaped life, life in turn shaped the land. Strange reptiles, giant insects, vast forests, all were products of this unique world. To step into Pangea's climate is not only to feel the burning heat or the seasonal rains, it is to see the beginning of a new chapter in Earth's story, one where the creatures of the land would change forever. When we think about life on Earth during Pangea, it is easy to imagine endless deserts and lifeless landscapes. And it is true, the heart of the continent was harsh, dry, and unforgiving. But Pangea was far from empty. It was a world full of strange forests, vast swamps, giant insects and reptiles beginning to dominate the land. To walk across Pangea would have been to step into a place, both alien and familiar, where life was testing out new forms that would one day shape the world we know today. Let us start with the plants. Imagine a forest stretching out in front of you, not of oaks or maples, but of towering conifers, cycads and ferns. Some trees stood straight and tall, covered in scaly bark, their leaves needle-like, reaching high into the sky. Others looked like giant ferns, spreading wide fronds into the air. Cycads, plants that resembled palm trees, were common across the continent, their tough leaves able to survive dry climates. In wetter regions, especially near the coasts and rivers, giant horsetails grew in thick clumps, forming swampy undergrowth. There were no grasses yet. Grass would not evolve until much later, so the ground was covered in ferns and moss-like plants. These forests were not only beautiful, but they also shaped the air itself. Plants during the late Paleozoic era were so widespread that they pumped massive amounts of oxygen into the atmosphere. This helped drive oxygen levels to unusually high levels, allowing animals, especially insects, to grow to sizes we can hardly imagine today. Fossils show dragonflies with wingspans nearly 70 centimeters wide, the size of a modern Imagine walking through a forest and hearing the beating of wings as a giant dragonfly passed above you. Millipede-like arthropods, called arthropleura, could grow to more than 2 meters long, sliding across the ground like moving logs. Spiders, scorpions, and other arthropods were larger too, thriving in this oxygen-rich environment. But insects were not the only rulers of Pangea. On the ground, amphibians and reptiles played out the story of survival and change. Amphibians had been the dominant land animals earlier in Earth's history. Many were enormous, like the Eriops, a bulky crocodile-like creature that grew to 2 meters long and lived near swamps and rivers. Its wide mouth was filled with sharp teeth, perfect for snapping at fish or smaller animals that ventured too close to the water. Amphibians thrived where water was plentiful, but as Pangea's interior dried, their rule began to fade. Reptiles, on the other hand, were perfectly suited for this new world. Their scaly skin held in moisture, and their eggs had protective shells, allowing them to survive away from water. In the dry heartlands of Pangea, reptiles spread across the deserts and plains, evolving into new and diverse forms. Some were small, quick lizard-like creatures. Others were larger, including the ancestors of future giants. One early reptile, Dimetrodon, stood out with its great sail-like fin on its back. It was not a dinosaur, but a synapsid, more closely related to mammals, growing up to 4 meters long. It hunted other animals across the dry plains of Pangea, its sail possibly helping it to regulate its body temperature in the extreme climate. The oceans surrounding Pangea were equally full of life. In the Panthalassa and the smaller Tethys Sea, fish, sharks, and marine reptiles thrived. Ammonites, shelled relatives of squid, floated through the waters in spirals of shell, while early sharks prowled the seas. Giant marine reptiles had not yet reached their peak, but the ancestors of creatures like ichthyosaurs were beginning to appear, gliding through warm, shallow waters. Coral reefs stretched along parts of the coastline, supporting ecosystems much like modern reefs, though built by different species. Life during Pangea was also connected in ways it never had been before. Because all the continents were joined, animals and plants could spread freely across the land. Fossil evidence proves this. We find the same species of plants, like the seed fern Glossopteris, in places as far apart as South America, Africa, India, and Antarctica. We find the remains of the reptile Lystrosaurus in both Africa and Asia, showing how species could travel across vast distances. Today, these continents are separated by oceans, but in Pangea they were neighbors. This is one of the great legacies of Pangea. It allowed life to spread far and wide, reshaping evolution on a global scale. But life was not always easy. The climate extremes, heat in the deserts, cold at the poles. Storms on the coasts forced animals and plants to adapt constantly. Some species flourished, while others disappeared forever. By the end of the Permian period, just as Pangea was reaching its height, the Earth faced its greatest extinction. Volcanic eruptions in what is now Siberia filled the atmosphere with ash and gas, warming the climate and poisoning the seas. Whole forests collapsed, oceans turned deadly, and countless species vanished. Yet some creatures like Lystrosaurus survived, crawling through the dry landscapes, enduring when others could not. These survivors would later give rise to the age of dinosaurs. To imagine Pangea is to imagine a world alive but unsettled. Forests of strange trees, swamps filled with giant amphibians, deserts where reptiles stalked their prey, skies buzzing with enormous insects. It was Earth, but an Earth in transition, experimenting with new life forms. Standing there, you might have felt both wonder and unease. The world was bursting with energy, but it was also fragile, ready to tip into catastrophe. And so Pangea was not just a continent of stone and sand. It was a living stage where plants and animals wrote the story of survival. It was the place where reptiles began their rise, where insects grew to impossible sizes, where forests breathed out more oxygen than the world had ever known. Life filled its corners, harsh deserts, stormy coasts, icy poles, and endless plains. And as the ages passed, life changed with the land, always adapting to the restless climate of a world that was both united and divided. Nothing on Earth ever stays the same. Mountains rise and then wear away to dust. Rivers change course. Forests grow, vanish, and return again. Even continents move, drifting slowly across the planet's surface like rafts on water. And so it was with Pangea. For more than 150 million years, this supercontinent stretched from pole to pole. But deep beneath its surface, forces were already pulling it apart. The story begins around 2,000 million years ago, in the late Triassic period. By this time, Pangea had already endured the harsh climates of the Permian and the devastation of the Great Dying. Life was returning. Dinosaurs had begun to appear, along with the first mammals. But while life was adapting on the surface, the Earth's crust was restless below. Beneath Pangea, heat from the mantle built up, trapped under the massive continent. The pressure had to escape. Slowly, cracks began to form in the land. These cracks, called rifts, stretched across the supercontinent like scars. Magma rose from deep within the Earth, filling the gaps and pushing the land apart. Volcanoes erupted along these fault lines, spewing lava and ash into the sky. What had once been one united world began to split into pieces. The first break came between what is now North America and Africa. Around 17.5 million years ago, the land began to separate, and seawater rushed in to fill the gap. This was the birth of the Atlantic Ocean. At first, it was only a narrow rift valley, but over millions of years it widened, until the continents drifted farther and farther apart. What had once been neighboring lands, joined in the heart of Pangea, became separated by an ocean that continues to grow wider even today. The breakup did not happen all at once. It was a slow and uneven process unfolding over tens of millions of years. After the first rift, other cracks spread across the continent. South America drifted away from Africa. India began its long journey northward, breaking free from Gondwana, the southern half of Pangea, and racing toward Asia. Antarctica and Australia detached, moving into the southern seas. The world that had once been a single landmass fractured into the continents we now recognize, each slowly taking its place on the globe. As Pangea split apart, the Earth's climate changed again. New coastlines formed, allowing moisture to reach further inland. The vast central Pangean desert began to shrink as rain returned to regions that had been dry for millions of years. Meanwhile, the creation of new oceans shifted winds and currents, reshaping weather patterns across the planet. The breakup gave Earth new climates, new environments, and new opportunities for life to adapt and spread. But the breakup also brought fire and chaos. Along the rifts, huge volcanic eruptions poured out lava across thousands of kilometers. One of the most dramatic of these was the Central Atlantic Magmatic Province, a massive series of eruptions that took place about 200 million years ago. These eruptions released enormous amounts of carbon dioxide into the atmosphere, warming the planet. Many scientists believe this sudden climate shift triggered another mass extinction, wiping out many species at the end of the Triassic period. Once again, the Earth cleared the stage. A new life, the dinosaurs, rose to dominate the Jurassic world. If you stood on Earth during the breakup of Pangea, you might have seen great valleys opening in the ground, filled with lava flows and newborn seas. You would have seen coastlines stretching where none had existed before. You would have felt the land itself shifting beneath your feet, not suddenly but slowly, a few centimeters each year, like the steady movement of time itself. It would have been a world of change, unsettling but full of new possibilities. The breakup of Pangea also left behind clues that scientists use today to piece together its story. In South America and Africa, we find identical fossils of plants like Chlosopsotaris and animals like Mysosaurus, a small freshwater reptile. These creatures could never have crossed the Atlantic Ocean, yet their remains are found on both sides. The only explanation is that these continents were once joined, part of Pangea, before drifting apart. Rock layers, too, tell the same story. Strata of sandstone in Brazil match those in West Africa, like pages torn from the same book and scattered to different shelves. Even mountain ranges carry the memory of Pangea's unity. The Appalachian Mountains of North America line up with the Caledonian Mountains in Scotland and Scandinavia, evidence that they were once a single chain formed when continents collided. Today they are separated by the Atlantic, but once they rose side by side, the Earth may forget quickly on the surface, but in stone its memory lingers. The breakup of Pangea reshaped not only the land, but life itself. As the continents drifted apart, species were separated by oceans, evolving along different paths. This isolation led to diversity, giving rise to new forms of life. Dinosaurs spread across the globe, filling every niche. Mammals remained small, but survived in the shadows. Plants evolved too, adapting to new climates and regions. Without the breakup of Pangea, the history of life on Earth would have been very different. And so the great continent that had once united the Earth was gone. In its place grew the world we know today. Scattered continents, vast oceans, and a planet in constant motion. But Pangea's legacy is not lost. It is written in fossils and rocks, in mountains, and in the very shape of the continents themselves. When we look at a world map today, we can almost see the pieces of the puzzle still fitting together. South America's east coast curving toward Africa's west, North America brushing against Europe, India crashing into Asia to form the Himalayas. These are echoes of a world long past, reminders that the Earth we walk on is never fixed. It shifts, it drifts, it breaks apart, and someday it will gather again. Even though Pangea broke apart nearly 75 million years ago, its memory is still with us. Every time we look at a world map, we can see its fingerprints. The jagged edges of South America and Africa seem to call out that they were once joined. The Appalachian Mountains of North America line up with mountain chains in Scotland and Norway, proof of ancient collisions. Fossils of the same plants and animals are scattered across continents now separated by oceans. Though Pangea is gone, its story is written into the earth itself, waiting for us to read it. But the legacy of Pangea is more than shapes and stones. It is the world we live in today. The very arrangement of continents, the oceans that separate them, and even the climate systems we depend on all trace their roots back to the supercontinent's breakup. The Atlantic Ocean, for example, was born when Pangea first split apart. The Himalayas, the tallest mountains on Earth, exist because India drifted away from Gondwana and later collided with Asia. The diversity of species across continents, from marsupials in Australia to elephants in Africa, was shaped by the isolation that came after the continents drifted apart. Scientists used the story of Pangea to understand how Earth works. The movement of tectonic plates, the slow shifting of the crust, has created and destroyed supercontinents many times. Pangea was not the first. Before it there were others. Rodinia, about 1.1 billion years ago, and Panatosia, around 600 million years ago. After Pangea, the continents will one day merge again. Geologists predict that in another 200 to 250 million years, a new supercontinent will form. Some call it Pangea Proxima, others Amasia or Novo Pangea. We do not know its exact shape, but we know it will come, because the Earth never rests. This cycle of supercontinents shapes not only the land, but also life itself. When continents come together, species spread across vast regions, competing and adapting. When continents split apart, isolation drives evolution in new directions. This is why the breakup of Pangea was so important. It set the stage for the age of dinosaurs, and much later it created the conditions for the world where humans would eventually appear. Without the breakup, there might have been no Atlantic Ocean, no separate continents, and no diversity as we know it today. Pangea also teaches us about deep time. The idea that Earth's history stretches so far back it is almost impossible to grasp. Human civilization is only a few thousand years old. Pangea existed for more than 100 million years. Entire species rose and fell during its lifetime, and even that was just one chapter in the planet's 4.5 billion year story. Thinking of Pangea reminds us how small our own time on Earth really is, like a single breath compared to the endless wind. And yet, this ancient continent is not just a thing of the past. In a way, it is still with us. Every earthquake, every volcanic eruption, every shift of the land beneath our feet is part of the same process that built and broke Pangea. The ground we walk on is not fixed, but moving, just as it always has. Our world feels permanent. Cities, borders, nations, but the story of Pangea reminds us that nothing on Earth lasts forever. Continents drift, oceans open and close, mountains rise and fall. The Earth we know today will one day be as strange and unrecognizable as Pangea is to us. So, what is Pangea's true legacy? It is a reminder of Earth's restlessness, of the cycles that shape life, and of the deep history beneath our feet. It is proof that continents are not fixed, that life is always changing, and that even the mightiest empires of stone and land can crumble and scatter. When we think of Pangea, we imagine deserts stretching farther than the eye can see, forests filled with strange plants, giant insects buzzing through the air, and reptiles prowling the dry plains. But more than that, we see a world in motion, a planet alive, reshaping itself again and again. That motion has never stopped. The continents beneath us are still drifting, slowly, silently, carrying us into the future. And perhaps millions of years from now, when a new supercontinent rises, some future beings will look back at the world we know, the one with 7 continents and wide oceans, and they will see it as just another fleeting chapter in the endless story of Earth.